Hey, I'm Thomas Ducia. I'm a cloud security engineer with Cisco, and today we're going to talk about using AWS Signer for build attribution and how we're using it to help improve our supply chain security. And if you're not familiar with AWS Signer, it's a fully managed service by AWS to help you do code signing for both containers and Lambdas. So our agenda for today. First, we'll talk about why we at Cisco for the CX Cloud product are using AWS Signer, what the security benefits are. Then we'll have some fun and jump into some code. We'll go through integration of Signer with AWS Lambda, and then integration with containers and ECS, and then we'll kind of talk about some next steps you can take to learn more. So first off, why use Signer? What are the security benefits? As the title of the talk probably gave away, being able to attribute your artifacts back to your build process is a primary one. Being able to validate that your artifacts have been scanned in your pipeline, defense in depth, and government regulations. So attribution of assigned artifacts. Let's talk about what signing is first before we talk about attribution. So signing is an industry standard way of proving the source and the integrity of something. So that's basically saying, I know who it's coming from, and in the time that person left their possession, it has not been modified. So why is that important for a build process? Well, we build an artifact, and there's a delay in time typically between building something and it actually getting deployed in another environment. So the trust of that time period is pretty important to say, hey, I know that what I built is what I'm going to be deploying into my environment. And why is that important? For us at Cisco, one of the big reasons is in our pipeline, we have multiple security tools. So we have SAS scanners, DAS scanners, we have third-party compliance, we have vulnerability scans, we have fire scans. We do all this stuff in our build pipeline. Then we create an artifact. How do we say that we know that the artifact that we created wasn't created by someone else and wasn't tampered with since we created it? Signing. So code signing allows us to say, provably, one, when we deploy, we know that has not been tampered with and we know its source. Two, if an auditor comes along and says, hey, you've deployed something in your environment, can you prove that it's been through all the stuff that you say it's complying with? And we can say, here's our signature. That signature can only be generated by our build pipeline. Our build pipeline does all that stuff. We're great, we're good. So that's one reason. Another reason is defense in depth. So like everyone, our ECR repositories for our containers and our S3 buckets for our Lambdas are secured. They're locked down. The only writable thing is our build user. But we can add an additional layer of depth in our defense there by saying, if for instance, someone misconfigures an S3 bucket or misconfigures an ECR repository and makes it publicly writable, a bad actor could come into our environment, could change that artifact between build time and deploy time. We don't know about it. It gets deployed on the environment. All of a sudden we have malware, some malicious code running in the environment. By signing our artifact, and this is the big reason behind signing, we can make it so when we go to deploy, we can validate that signature. If that signature hasn't changed, we know it's the artifact we created. If the signature has changed or the signature is not valid, someone has tampered with it. So it just adds another layer of depth to the IAM permissions we have scoped on our ECR and our S3 bucket. Is adding, hey, someone would actually have to get it into access to Signer to be able to re-sign an artifact on top of that. Another reason beyond the build attribution is government regulations. So we're Cisco, we serve a lot of government clients, and there's a lot of regulation coming down. Here's a quote from back in 2021 from the White House from an executive order, and it's talking about maintaining trust of source code and ensuring the integrity of code. That's telling you need to sign your artifacts and you need to validate signatures of anything coming into your environment. We also, with the government, like NIST 853 has component authenticity requirements. So if you're filing government regulations, there's component authenticity requirements of NIST that say you have to validate the authenticity of any artifact that comes in your environment. Again, that's talking about signing. So government regulations is a big driver as well for a company like Cisco. Cool. So those are the reasons why. Now let's get into the fun stuff. Let's talk code, let's talk architecture. And we're going to start with AWS Signer and how we integrate it with Lambdas. So this is a simple architecture diagram. And when I show you the code is just as simple as the architecture diagram. On the top, we're using GitHub Actions. So our GitHub Actions is our CI pipeline. So what we do is, in the pre-signed artifacts, most people take their artifact in their build pipeline, they'll zip it up, they'll stick it into S3, and then they'll deploy it from there. Adding in Signer is a single call to Signer that says, sign this artifact. Signer then manages creating a new artifact with that signature and putting it back into S3 for us. So how does that look in code? At the top, we have some AWS CloudFormation. So the only AWS CloudFormation you need is creating a signing profile. So you create your signing profile, about 4 lines of code. You have this profile. It wraps the crypto that's going on behind the scenes. It's all wrapped in those 4 lines of code. And then from our build script perspective, it's pretty simple. The first thing we're doing here is you can't use just an object reference. You have to have a versioned object reference in S3. So we grab that versioned object reference in S3. The second one is you'll see we're calling AWS Signer start signing job. And we pass it source, destination, and that signing profile we created above. Fire that off, and then we basically wait for Signer to finish with the job ID that it sent us back. That's it. We now have a signed Lambda sitting in our S3 bucket that we can deploy. So how do we do signature validation? Architecture diagram is even simpler, and validation is even simpler for Lambda. So we're just going to deploy our Lambda like we normally would, and AWS Lambda actually manages talking to Signer, looking at the artifact and doing all the signature validation for us. So code-wise, this would be our Lambda pre-signature. What we do is, at the top, we create a code signing profile. What this is saying is we have the signing profile that we created, and then we are saying enforce it. You could also say warn. So if you didn't want to reject it all the time, you just wanted to warn with logs, you could. But you're just saying, here's a profile, here's the warn. And then if you look at the very bottom, the only change that we did to our function is we added this one line pointing up to our signing configuration. And now any deployment that goes into our Lambda, if it's not signed properly, if the artifact is changed from the signature, it'll reject it. So some lessons learned, pretty straightforward. You could probably implement this in under a day, probably half a day in your build pipeline. There is some quirkiness around the signing profile. You need to have the version R, not just the signing profile. So make sure you do that. That caught me the first time I was doing it. And then a big one, and this is probably the biggest impact, is if ever in like a dev or sandbox environment, you've gone live into the code console and hacked your Lambda a little bit and changed the code in it, you can't do that once it's signed because it's going to restrict it. So it's a consideration. So in sandbox dev environments, you might want to disable code signing and have it only in your stage or production environments. Great. Let's talk about container signing, and container signing specifically with ECS. This is going to be a little more, ECS is less integrated than Lambdas are, so there's a little more complication to it, but I'll run through that. The signing portion of it is pretty similar, and as you can see, we have our upload step where we upload our container to ECR. So very similar to what we had before with Lambdas. What we're going to add here now is instead of a call to AWS Signer to sign our container, we actually use something called Notation CLI with an AWS plugin in it. So we call the Notation CLI. That CLI, kind of like what Signer did, it handles everything for us. It'll call Signer, and it'll call into ACR. It'll generate the signature through Signer, and then it automatically puts a signature and an index right next to our container in ECR. So code-wise, what that'll look like is, again, similar to the zip file being versioned, you need the container SHA. You can't use a container tag. You have to use the SHA hash. So you grab the SHA hash from your container, and then you just call the notation CLI. You call it notation sign, you give it the container you want, and you give it the signature profile you want, and it all behind the scenes talks to Signer, talks to ECR, uploads all the stuff for you, and then all of a sudden you have a signature sitting right next to your container. So validation. So we're going to do a two-part validation. We're going to do a deployment validation, and we're going to do a post-deployment validation. Because currently Signer is not integrated directly with ECS, we can't just flag it like we did on Lambdas. So what we'll do here is we're going to add we add a verification step before our deploy step to make sure, hey, before we try to deploy this thing, let's make sure we still have a valid signature. So in our validation step, or verify step, we use that same notation CLI, and we say, verify this for us. That notation CLI talks to ECR, it talks to Signer, validates the signature for us, tells if it's good or not, and then we can go ahead and deploy. So code-wise on that, how we do this, and part of when you're deploying an ECS task is you can have multiple containers. You can have your primary container and a bunch of sidecars. So we use a CloudFormation change set, look at the change set, describe the change set, and then we parse that. So because a change set could have multiple containers in a single ECS task definition, we iterate over those. And the main line really working line though, that isn't just boilerplate, is that notation verify Docker image at the bottom. That's calling that CLI to verify each one of our Docker containers we're deploying into our environment to make sure that every single one of them signed. Because again, we could have a sidecar that we needed to make sure we signed as well. Cool. Well, that got us our deployment validation. What happens if someone can bypass deployment and tries to stick an artifact directly into our environment? How are we handling that? So this is a little more complicated. What we do is we basically watch it we have a CloudWatch trigger that'll trigger a Lambda. That Lambda, instead of the CLI, can use the notation API. One caveat there is it's only written in Go, so you have to code it in Go. So you have a Lambda that'll call this notation Go API, and similar to the CLI, it'll interface with ECR and AWS Signer for us, tell us yay or nay if the signature is good, and then we can act on that if it's bad. We can send an SNS notification. Right now, we at Cisco, we just alert on it with logs, but you could, in theory, go ahead and shut down that container as well automatically. So code here, there's a lot more code, so I'm just covering the meaty part of it. So this is the Lambda meat. So this is where when the Lambda receives the message, and it'll look and check if there's a container running, a task of running. And if it's running, we can then call right there, we call the notation verify with the verifier and the repo URL, and Signer will go ahead and do the verification for us. So there's more boilerplate around the events and triggering, but that's really the meat is you just call the API handles verifying the signature for you. So, some lessons learned from this. ECR is well integrated with signatures, and it just kind of works. ECS takes some of this custom logic for us to build a full-on solution. So you kind of work around it right now. It can be difficult relating right now signatures with the index that's created and the container. So when you look in ECR, there's a small correlation, but not a direct correlation. So you end up having to use a CLI to relate those things to figure out, hey, which of my signatures, if I want to move this stuff, go together. And additionally, deleting containers requires an extra step if you don't have lifecycle policies turned on. So if you delete a container because there's 2 new artifacts in there, you have to make sure you're deleting those. And because they're referential, the best way to do that is through some CLI that AWS has documentation on their site. But it's not always easy to you can't just go delete a container. You have to make sure you delete the signature and the index file if you don't have lifecycle policies turned on. So next steps. You can attend this workshop. Nayaz Khan, the GM for Signer, is giving a workshop that goes through some of the Signer so you can get hands-on with it. The first blog I have listed here goes through the Lambda signing process, so you can go through kind of what I've talked about. You can go through the blog and kind of cover the same stuff. And then the last blog is signing with ECS and the patterns on that, so you can review that blog as well to kind of cover what we covered. Thank you very much.